and policy for electrical systems. So we call it dynamic charging. Electrodes are more the physical thing which we build, but what users, truck industry benefits is the dynamic charging. So the power maturity, my own in the opening remarks, is very important for the companies. They have solutions that are mature. And what better way to do that? So basically, some of the key tracks are very powerful. I think are very noisy, not so very easy. And they do a lot. But what we see is that that's a solution that are used by trucks and different trucks. And this is very important to point out that there are different drivetrains out there. You can hybrid, you can battery, you can fuel cell. They all have pros and cons. Leverage on these days. But they all benefit from adding a charging system. So, for instance, if you're using green molecules, you don't get expensive. If you then can have a majority of your mileage electric instead, that's a massive reduction in your operating costs. When it comes to batteries, you're talking about both the charging, easing impact, and the reduction in battery. In addition to this, you can see a little bit of the future. I'm from Sweden. They have trucks that are very long, now 34.5. If you look about 72 tons. If you want to have those trucks going out in countries, then the battery electric solution has even more dynamics than the dynamic charging address. Or if you think about autonomous trucking, we haven't invented at all. I would say that the past day and a half. But in many other venues, people talk about, especially driver shortages, looking more to autonomous on these short applications, and this also solution that doesn't impose any downtime. But what we're talking about when we talk about infrastructure, we're talking about you have distribution connection to the grid, you need substations, and then you have electronic lines. These are what we talk about in the scope when we talk about the price of the system. This is what we come back to. So how is this developed and how do we find ourselves today? So when we start, we come back to the maturity and any dynamic charging system. It needs to survive on a busy highway. Because we would say when we look at the economic system of the US, it's on these highway lanes where we want to have it deployed. When thousands of trucks driving every day, can the system endure having maybe 10,000 trucks driving over it, that lane or under it every day? That was a question when we started, and we need to answer. Then we also looked at what trucks are available, and when we started 30 years ago, there were very few vehicles available. But the biggest research gap or the development gap that we were working on is then the thing that connects the trucks with the open country lines, which is called a pantograph, which can connect while driving. They need to fit on the tractor unit, it needs to be able to transfer the power that they need, which was defined by the truck manufacturer about 200 kilowatts of power, so that this traction to move, but also to charge the battery so that it can read the dynamic charging infrastructure to charge on. And it has to work at high rate speed. So then, if we go forward to where are we today, so now we've had installation first in Sweden 7 years ago, and now past 4 years in Germany, including on some of the biggest highways in Germany. So the Franklin A5 highway has about 15,000 trucks driving on it every day. And so in that lane where we have the system now running for 4 years, I would say about 20 million or so trucks have been driving that lane. And I remember talking to one truck manufacturer before saying that once you do this, there's a probability of 100% that you would have truck hitting that pole. Okay. Now I had 20 million trucks driving by, and not a single one is full. So I think they're often in the probabilities. But we also see that we have very high uptime, very high reliability, and of course, one of it having things happen, but you then have incident management and the highway company themselves, the outbound in the house, so the system is now ready to be rolled out. They are convinced technology works on the highway. We also see that the pantograph that now meets the requirements, we can introduce more power, we transfer 500 kilowatts of power through the pantograph, because the truck can receive this much power. So that's then a luxury problem to have. So the minimum requirements working at high speeds that is fulfilled. And the trucks that we have are used by real trucking companies. They're not researchers driving around with data, we do that also. Those are separate trucks, they're maybe 3 or 4 other trucks that are on top. Okay, but there are 22 trucks out in real highway operations with trucking companies that use them to carry goods. And that shows that both the infrastructure and the vehicle solution meets the requirements of the operators, of highway operators, or construction operators. And that's very important, especially if we want to have comparison in the dynamic part of solutions. If our solutions are not even on a highway, if they're not used in real operations, then these cost estimates are very to use. So let's talk about the cost. And here's the figure from IPF. They know that many reports make one set of assumptions, and then maybe someone does a report do another set of assumptions. They go, okay, let's do a Monte Carlo analysis, do 1,000 different assumption sets for diesel, for battery vehicles, for dynamic carbon, battery vehicles, fuel cells. What you see here is a range, the bar for the range. And you can see that dynamic charging has the lowest cost in the assessment, and also the range is the lowest. Because it has high energy efficiency, because using electricity directly compared to fuel cells, which is indirectly, you have high resource efficiency. The vehicles can have less batteries, they become cheaper, and the operational aspects will not factor in there. But of course, if you don't have any downtime because you don't have to stop the car, or if you stop where the driver likes to have the food, or if the truck is stopping overnight and it's necessary, you have to look for a charger. The low operational flexibility that's not included there, but even so, it has the lowest cost. On the busy highways, of course, all the assumptions are to put in the infrastructure where you expect to have high utilization. So the cost, and this is a study funded by the European Commission, by the way. Then we have the greenhouse gas impact. This is from the Umweltbundesamt, the German environment agency, looking at 2030. How do we reach 2030 climate goals? Well, if you use probably domestic electricity, because Germany has a goal that 1/3 of the mileage should be done on either of heavy-duty trucks in 2030 should be done by trucks using electricity, either directly, so batteries or the line, or indirectly, if you use hydrogen, green hydrogen. But importing green hydrogen will be very difficult. There are ships or production activities for that. So it will be domestic electricity. And if you use German domestic electricity, the savings for hydrogen fuel cells is negative. It's even worse than diesel, which is worse than negative. Okay. So we have to use electricity directly. Now then I come to lead into the cost estimate that we did, the break-even calculation. We'll come back to the 5% later. So we looked at where is the truck traffic happening. It's very concentrated on the road network, both in Europe and worldwide. We also know one of these graphs is right. It's the distance to go away from the highway is typically very little. So in Flanders, it's 25 kilometers in 95% of the cases. In Germany, it's less than 50% in 89% of the cases. So the distance away from the highway is very limited. So we sat down, and we have to go back up. So we sat down together with DHL. They, of course, have a big fleet. They have lots of operations. And the question that CEO gave us was, what's the break-even now? If we build a core network on this 2,000 kilometers of Germany, just 2,000 kilometers, how many trucks do we need to have the savings to pay off that? So here are the assumptions that we can discuss with DHL to be conservative. Okay, so we look at. Now I have to stand closer so I can you remember. So we look at what is the diesel price, but this is 2030. So looking at a system of 2,000 kilometers. We started with the operators, as we said, a diesel price of 1.6 euros. So this of course fluctuates, but we don't think it will be dropping much further than that, or go maybe it can go higher, but it's a reasonable estimate for 2030. Electricity price, we looked at the wholesale price, that if you have a big system, typically it's about 8 or 9 cents per kilowatt hour, but then of course you have some grid fees and so on. So we had a 14 cents assumption. Diesel truck, I think today it's already a little bit around higher, but then we also assumed for a battery electric truck, even with a small battery, conservatively, let's say 200,000, it could probably be less than that. And then interestingly, we talked to them, what do you expect for the maintenance cost of an electric truck? They said, oh, we have lots of electric vehicles we already have experience with, and yes, the maintenance hours that you spend is probably less, but you have special technicians, so maybe let's be conservative, assume it's the same. So all these assumptions flowed in, and we looked at how much would you drive on the overhead contact line, how much would you drive on power using the overhead contact line, how would you use with a depot charger, and then we found the TCO difference would be almost 50,000 euros per year. And if you spread that out over the kilometers that you drive under the overhead contact line, you have about a possible fee for a break-even system, about 85 cents per kilometer. And then we looked at the infrastructure side. And here we also took a more conservative assumption. So the figures that Raymond quoted about the cost per kilometer. So the systems that we already built in Germany, so the 10 kilometer, for instance, outside Frankfurt, then that cost was about between 2 and 2.5 million euro for each double kilometer. So for a lane kilometer, it's more closer to 1. Okay, but then we said, yes, there's been some inflation in the market, but let's also be very conservative in our assumptions. So let's take even a 4 million figure. Okay, nobody could doubt that you couldn't build it for that figure. Okay, and if you want this 2,000 kilometer network, you need an 8 billion investment, would easily last 30 years, and then you need some operational maintenance. We have 2%, that's the 160 million. Then we get a total cost for running the system of 620 million. And if we divide that by the 85 cents per kilometer, we get a needed number of users of 13,000 users, which, if we look at the total truck fleet of Germany, domestic trucks of Germany is about 360,000. Then you get about 3.6% of the truck fleet that you would need for break-even. One driver in this case, David, I see you're looking very skeptical at me. Yes, of course, in Germany, there's this toll discount that we could add to this calculation. So we know that the trucks, they get an extra 16-cent saving when they're going, they don't have to pay that CO2 toll, and they have lower also fee on the infrastructure fee. So you have in total maybe then a 25-cent saving for each kilometer they're driving. And if you have these high mileage trucks, here we assume 140,000 kilometers of the total mileage, not only on the highways, then you would have the system. So that's a figure that we then also communicated to the German policymakers, together with DHL and Scania and Continental and others who are very supportive of the system. We also looked at the uncertainties, so looking at what if the diesel price is higher, what if it's lower, just get a feeling of how robust are these findings. And we found that if the mileage drops, or if the diesel price drops to 1.2 euros, I don't think any policymaker will allow the diesel price in Germany in the year 2030 to be 1.2 euros. But even if it would be, the required fleet to break even is instead of 30,000, and then we do 20,000, which still is a very realistic figure, or a very achievable figure. And to ask the question about the production capability, we saw the figure before for 70,000 zero-emission trucks produced in 2030. I think the German figure alone from the manufacturers is 75,000 trucks they expect that they can produce in 2030, zero-emission trucks, if the infrastructure is there. Okay, this is the question: how do you get the infrastructure? This brings us a little bit to my final point, the policy making, and I have to do a little deep dive about Germany. Not because I live in Germany, but because Germany plays a very central role in the European transport system, especially for long road freight. And Germany has climate strategy. It's called the Gesamtkonzept Klimapolitik der Nutzfahrzeuge, so the overall strategy for climate-friendly trucks. You also have climate laws, and they relevant to technology. They say one of the 3 technologies of trucking they support is dynamic charging over equipment lines. We do big innovation clusters. It's also anchored in the recent climate law from October. And had you asked me in October or a year earlier, I would say the German budget for climate-friendly vehicles is about 4.5 billion euros for vehicles and infrastructure. Clearly, if you have 5 or 10% of that, you can do an innovation cluster of a very big size. Okay. Then there was the constitutional ruling about some month ago, which said, yes, last year you spent 1.4 billion on clean trucks, okay, for subsidizing the heavy goods vehicles, but for the coming years, not just so the ruling was not specific to the clean truck, was what the whole budget process. But the implication in the budget process is for the next 4 years in total, for all the zero-emission trucks, for all the stationary chargers, and for the continuous system, there's about 85 million euros in the budget. So of course, this is something that's upsetting the whole industry. So I can say we're not happy about it. I can say MAN, Daimler, I can say the whole trucking industry. Actually, they call a press conference in the Bundestag, the federal building of the Bundeskanzleramt, the main press office of the government. They have a press conference saying, this is ridiculous. You're not going to reach any goals. You're not going to have any zero trucks. So that's a little bit of a damper. Everybody has to adjust their posture and to make it through that time. But what we see is that there is a lot of interest in dynamic charging, and I here want to highlight China, who's now in the spring of this year, the very release for launch 2 dynamic charging test tracks with our economic lines. And I also want to say that the policymakers are also waking up to think Justin Lane had a very nice statement yesterday evening. So ERS solves the problem that we are not yet, the many people are not talking about yet. Okay, but I can sense that the policy discussion is moving. So we say not just that it's cost assessment, but also the how do we stay? How do we handle the lack of space that we have in Germany that's important for parking spots, the grid aspects they all talk about, and these things are becoming more and more aware. As had a federal European Parliament last week. This is also the point of stress. There are a lot of facilities in dynamic charging and station charging to address the challenges that we see with battery vehicles, because the industry, the truck manufacturers, they want to ramp this up. The operators want to have them, and we want to have a system that can handle big volumes. This is what we can see, for instance, in the field trial of the A1, northern Germany. This is a system that can be built to handle high number of vehicles. It doesn't require new space just for the substation, but broadly you don't need any extra space to store. And when it comes to stakeholders, instead of having 10,000 warehouses to coordinate with, in Germany you have one company that owns the whole highway, the Akerman GmbH. They have already gathered 4 years experience. They say that it's ready to be rolled out. So the stakeholder management is much easier. And lastly, the users of the system, so the trucking companies. So in within Parliament, this is online, you can see the speaker before me. The speaker before me was from the European Trucking Alliance, and it's he also worked for a trucking company, and she says in their roadmap, it's very clear that they want battery vehicles, they want station chargers, they want chargers at the warehouses, and they see the need for the dynamic charging, because there's not enough space and time to do the charging otherwise. And this is also then supported with statements from the DHL CEO, Tobias Meyer, who says they see a synergy. It has to be, it's not either or, not stationary or dynamic, it's the combination. And just 2 weeks ago, DHL started using one of the trucks in the field trial, and then they also communicated that these are technologies we have now. And this is a core message that we're setting to policymakers. There are solutions available now that work, that are economic, that can be scaled. Use them. Thank you.
Patrick, I really like your audience of fuel cell electric vehicles, which are fossil fuel cell today. Time forward to quick questions before we have lunch. So, Patrick, you self have your lane in e-highways, and your employer is another lane in the rail industry. From a more human point of view, how much sense would it make in your right to build an e-highway in parallel to an existing mid or long range rail connection, which is already in place, or land is part of the thinking for the world?
So Siemens were very much into any rail expansion, and I know that there are coalitions of the European rail coalition wants to see this 1/3 of the mileage coming onto the on rail. But even that coalition, when they make a forecast how much road freight will be in 2030, will be more road freight than today, even with this magnitude. And as we showed in your slide, the evidence that is still happening is not bad. So we realistically are facing a very big road freight sector. So yes, invest in rail, and I think this budget, the quarter system will affect the 40 billion euros of the German plan for railway. Okay. But I think that will happen, and that's also voters on trains, they want to see that happen. But there's still a need to do something about the road freight sector, and I think that's a good opportunity to know how the rail sector can help the road sector.
Then one more question.
If we compare these various presentations on ERS, something that's not been mentioned is the potential benefit in terms of battery life. If the batteries are recharged dynamically, doesn't that extend battery life? And then has that been factored into the TCO calculation?
So there are 2 ways to look at this. One is, of course, if you have the trucks connected either dynamically or connected in the station, so they're connected most of the time. Okay, so if the sensor is connected, if the truck moving, they're connected. That means you can charge the batteries slowly and gently. Okay, there's no high power on the batteries. So that should have an impact on the battery, but of course also reduce the size of the batteries. And so I think there's an interplay here. So even you don't want to double count. You don't want to say, I'm gonna have a much smaller battery, okay, so I have that saving. And then instead of charging it at megawatt, I'm charging it at 200 kilowatts, and therefore, but it's a much smaller battery. So then maybe, but of course, if you don't reduce it so much, the French council industry said, especially in the beginning, you start rolling out the infrastructure, the trucks need to have capability to go far away. Okay? So they will have big batteries in the beginning, but once you really ramp up the fleet, you do that when you have infrastructure in place, that's where the investment on the bottleneck in supply. Then you want to have smaller batteries, and then you can have, but yeah, okay.
Patrick, can I help you a little bit with that one? So the first thing is that when you're on the ERS, much of the time you don't need to be using the battery at all. So electricity comes from the wires and goes straight to the motor. The thing that kills the battery is when you charge it fast. We use the C rate to describe that. That's essentially the number of hours that you take to charge the battery to full. So 1C means you charge it in an hour. That's reasonably fast. If you're on the ERS for 2 or 3 or 4 hours, you can be charging slowly at less than 1C. If you are on a fast charger, you have to charge in half an hour, then you're at 2C or 3C. And that's when you're really damaged battery. So the two factors are that you can charge, that often you don't have to use the battery at all when you're on the ERS. You're using, and that is 15% more efficient. Now it's a lot more efficient just using the electricity off the wire and not going in and out of battery. And so it's much more efficient and it doesn't use the battery. And then when you need to charge the battery, you've got however long you've got on the ERS. If that's 2 hours or 3 hours, then you only have to slowly charge over that time. And that gives you a big benefit. So the overall answer is a big advantage from battery size and battery life.